Uh, Thanks, Venkat. I'll start with a little brief history, like how I ended up on this stage talking about AWS. Like a couple of months ago, like Venkat pinged me and like we're gonna do this thing called data at scale, and like we would love Pinterest people to talk. And I have my own like scaling Pinterest talk, which I usually do. And but he was like, no, I really want to know like whenever like somebody gets on stage and like we build something awesome and like it's powering the whole infrastructure, like we want to know how they actually like build it on AWS because to us it's a joke, but we really want to know what happens behind. So with that, like I volunteered like, hey, I'm gonna do this for you, but here I am. So let's start with a little brief background, like how we ended up on AWS for Pinterest. Like initially when we started to build our infrastructure on Rackspace. We started with a small web engine and like one MySQL database, and we were starting to like code the whole thing up. And boom, one day we had a good friend like who got into YC and like, hey, guess what? YC gives you? It gives you free Rackspace and AWS credits. And we were like, okay, what are you gonna use? It's like, I'm gonna go with Rackspace. So we were like, okay, can we get the free credits of AWS? And like that's how we got in, and like we moved the entire thing to AWS. And still like today we're like paying them a lot of money and they're happy. It's so I was talking to a couple of people like right before this talk, like how we love AWS. That's how they put it. But it's actually like funny, like it's a love-hate relationship. It's like that girlfriend which you can't live without, but you can't get rid of her. And today is like this talk is completely going like we love this, but why can't you just do this one other thing that would make our life easier, and how we actually get it done at anyhow at the end of the day. So the humble beginnings, like we moved the Rackspace infrastructure to Pinterest, where we had a very small instance, web tier, some Python code running, prototypes, and like then we have the MySQL database on another M1 MySQL, M1 small instance, like 2 gigs each RAM, and everybody's happy. Like there's no traffic, it's no big deal. So that's how we got started. So as we started to ramp up, like build more features and like market it, and like as people like started getting on the site, and we were like, okay, like guess what? Like this query is slow. Like what do we do? Bump up the instance. So like we moved to M1 large, 15 gig, 34, 68. Life is great unless you hit the limit. Like we don't have any instance bigger than this. Okay, what are we gonna do here? Then comes like, okay, like can we move the biggest table, like the biggest workload to its own database? Like, hell yeah, we could do that. Like we are on Django. Django has routers. You could like write some glue code in like 10 lines. Like if this is this table, just go to this database. So we took the largest table by far, pins, and put it in its own database. M24XL, 68 gigs of RAM. Everybody is happy. And then the next biggest write-heavy table, which is followers, and like put it on 15 gig, and then everything else on 15 gig. You might wonder, like, why did you put it on a 15 gig box? The answer is like, I don't know why, but Amazon decided to put 4 drives on a 15 gig M1X large, while 2 drives on every other box. We don't know why, but that's how it works. So since we had like a large write-heavy workload, we put 4 drives and RAID 0 them so that we could get 4x. It's basically striping your data across, your bits across 4 drives so you get the best write throughput. And everybody was happy. Like we wanted more IOPS. We started leveraging this M1X large, and like everybody's happy. Like the read slaves kick in, and like they just handle all the reads, and like all the writes go to the master, and logical partitioning was working great. And as we scale more and more, like we were adding more read slaves, which was causing pressure on the master. Like, okay, the slave is delayed by 2 minutes. And the next minute, it jumps to 5, 7. And we were like, okay, that's not good. Like, I just followed this user, but when I refresh the page, it says I'm not following them. And they click it again and again, and like all sorts of bugs creep in. And we were like, okay, like how do we deal with slave lags? I'm going to talk about the slaves and like how we solved it in a little bit. But at this point, when we were leveraging like AWS instances for databases, everybody like starts on EBS because it's the only way you can persist your data on AWS. Because any node on AWS is ephemeral, like anything can disappear at any point of time. So we started there, like it's storage on demand. How much ever data you want, you could just like spawn a drive and like mount it to a server, and like you get the data you want, storage you want. It has snapshotting, like okay, this server is slow, like can I just upgrade? Like you snapshot your drive, and you boot a new EBS volume from that snapshot and tell like, okay, replicate from here, and like boom, you like migrated with zero downtime. The durability is great. Like you could just snapshot an EBS instance, and like the snapshot is in S3, which means like the snapshot is available anytime, anywhere in the world you want. But the bad thing about EBS is the variability. Like at some point, when you are seeing your beautiful Munion ganglia graphs, you would see like, okay, this database is slow for the next 5 minutes. You don't know, the IOPS just shot out of the roof. The latency is really bad, and you're getting timeouts on the front end, but you're like trying to figure out like what exactly is happening. Like that's the beauty of EBS. Like it just gives you all this latency and all these problems for free, and failures are just fantastic. Like and we have these, and we just multiplied the problem by 4 times because we have these RAID 0 configurations, and one slow drive in a RAID means the whole RAID is like just slow, and it won't work. So these are some of the things we learned. Like, and one important learning we had was like, if at all there is an outage at AWS, the first thing that goes down is EBS. So when we were planning about high availability, and we spoke with a lot of other peers like Airbnb and like others, like we learned like, okay, guess what? Like Reddit and other guys don't run on EBS, so why not we could do that? And we like tried out using ephemeral nodes as the storage, and like we have multiple copies in different daisies. And once again, everybody's happy getting off EBS. Network. My God, this is the most beautiful thing in AWS. Like, it works, no doubt. Like, you can contact node A to node B, it works. But at scale, and like, when you have like thousands of servers, like, the beauty is like, node A can talk to node B. You just don't know why. It just happens only for minutes, and you could see the graph, beautiful graph, like, okay, I have those many writes, and there's like a complete blank graph, and again, the writes continue. It's like, okay, what exactly happened during that gap? You don't know. It's just this node cannot talk to another node. And it's actually like, people think like this is a disadvantage on AWS, but actually it helps us like code defensively. Like as Pinterest engineers, we like always like embrace these limitations and like work towards these limitations as advantages. Like, so let's say like we can't reach this node, like we retry another node. If you have like, do you have a replica copy of this database or this cache? Yes, okay, then go for it. Like try to access it. If not, try something else. If not, if everything else fails, yes, let's just fail this transaction. We're gonna throw a 504 or 502 or whatever it is, but this actually helped us think like, okay, like anything in the cloud could be unavailable at any point of time. So how are we going to react to this? So we embraced failure early on. Like, okay, nothing in the cloud is permanent, or it's going to stay forever. So how can we render our web pages so that it's modular? Like maybe I can't show a recommendation things, like I can't show recommendations for the logged in user. The database is down. Like how can we be modular? Like, okay, the timeout is 400 milliseconds. Let's just act that thing never existed and render the grid, and like the user might not notice or something. So it actually helped us, and like we built an amazing product which is modular enough to like failures. Noisy neighbors. My favorite thing, like running cache on AWS is one of the amazing challenges, because you're trying to run a memcache node and everything is virtualized, and you don't know who your beautiful neighbors are. Somebody could be running a MySQL, and MySQL, like they could be dumping MySQL and like backing up to S3, while some others could be running a RabbitMQ, which is powering a huge website or something. And guess what? All these neighbors share one network pipe, and you're trying to run your memcache on this one poor physical machine, and that is powering like the critical part of your website. Guess what? You're just unlucky in this case. You got to take a hit and move to bigger instances like M24XL, where you do not have any neighbors. You get the whole physical box just for yourself. And maybe you could like virtualize and run multiple memcaches on that machine so that you do not have this problem. But this is one of the things that bite us a lot every like once in a while. Like we file something on AWS and they're like, oh, guess what? You're fine now. It's cleared up, but who knows like what your neighbors are doing. And then as we progress like through all these pains, like we hit the ultimate wall, like, okay, we have been running these M1 15 gig boxes for a while, and the data is exploding, and we only have like 1.6 terabyte because you got 400 gigabyte drives, and you have this 1.6 terabyte limitation of hard drive. So we'll have to partition our data, and we have to partition it smart enough that you could grow for the next couple of years. So we took a step back, re-architected. Just like every other company out there, we did some bit twiddling. We learned our lessons from Facebook and others, like we generate the IDs, and which has object type, shard ID, and the MySQL increment, which defines like where a piece of data is stored and which server has that piece of data. So once again, like everybody's happy. We are able to grow. The site is fine. Like we could split shards during peak whenever we have like traffic peaks and all. Like as the traffic grew, we split shards. And guess what? Like 3 months down the line, when we were doubling every 90 days, we had to split shards very often. And we did not automate this process enough that, I mean, we just built this infrastructure and like we did not have the time to automate it. So we were just like, okay, we're gonna release an Android app and we're expecting these many users. And that means that correlates to these many QPS. So like, how are we gonna support it? Just split the shard, we'll be fine. So more machine, as we threw more machines at it, more failures hit us. Like every like once in a while, we had to do a failover, and like one ephemeral drive would go bad in the RAID, and the whole machine would have to be failed over. So, and during this play, like we were hurting the availability because the failures were just so many. So during this phase, like we saw a light. The SSDs came in, and like, oh my God, like this is the best thing that can happen to us, and like, what a timing, like, okay. Because we were thinking like, should we just use Direct Connect and move this MySQL out of AWS and like use some great machines, or should we like stay? And like AWS was like, hold on guys, we got it. And then they gave this amazing thing called SSD, and we were so happy. We jumped right in and we ran our MySQLs, we did our performance testing, we tested our backups, everything worked great. We were able to consolidate a lot of machines into one SSD machine. And once again, we were able to like shrink our MySQL fleet. And thus gladly there were new machines, so the failures weren't like not that bad. So once again, everybody is happy and we progress. So one of the things like we observed, like when you actually choose AWS for your startup or for your project, one thing you need to embrace like right very early on is like disaster recovery, because Amazon has this beautiful effect, like anything can disappear at any point of time. So what are you gonna do when your database disappears? Are you ready for this? So we were forced to think early on and like prioritize, like how do we do DR? Are we gonna do EBS, or are we gonna run ephemeral drives and have multiple copies in different AZs? And how do you do backups? And how do you like back this data up? And actually the most important step, how do you validate these backups? How do you know these backups work? So these were the questions we just brainstormed and like, oh my God, we gotta answer every one of this. And we took a step back again, like prioritize, like how do we do disaster recovery, and like gladly we got that project done. The ops team did a great job. And once again, like we were like, okay, I think the backup works, which is what we wanted to answer. As I say, like Amazon Chaos Monkey effect, like Netflix built this awesome tool called Chaos Monkey, which actually just like kills servers randomly and see like Netflix goes down. But guess what, like Amazon actually gave this tool to us for free. Every once in a while, like, okay, I see a lot of 500s, like, guys, do you know, guys, what happened? Like, they'll be like, okay, let me just check the log, and like, oh, this server is down or something, and we go into AWS and like terminate it. It's like, oh, that's the database. Like, it's terminated. Like, yes, it is. Okay, guess what? We're gonna do a failover. Like, promote the slave to master, and like, boom, failover, postmortems, and like the beautiful things. But yeah, it's great. Like, Chaos Monkey is free with Amazon, and like, you should just totally use it from day one. I was sitting with some of our ops folks and like, hey man, I'm like doing this AWS talk. Like, can you give me a set of limitations that AWS, like, oh my God, yes, I've got like a huge list. They pulled up their laptops and like they started like, I've compiled like very basic, like, which I felt like, oh, this should not be in AWS. Like, we store a lot of files. All our media is stored on AWS, and like there are bucket size issues all the time. Our APIs just fail, and we call AWS, like, hey, what's happening? And they're like, just hold on. They press something, and like, okay, you're good for 2 months, bye. They would do that to us. And API starts responding after some magic number. It's like, oh yeah, your listing API we only support listing until you have these many things, these many objects in your directory, and you cross that, we are not gonna respond to you. It's like, okay, so we had to reshard all the objects in all the directories so that the listing API works, and like some other things. And personally, my favorite is like, we have to constantly keep an eye on packets per second, because that's the #1 limitation which we would hit all the time. So one of our hottest memcache is user cache. Like, we render user objects all over the place. We show users every time. So we were like, okay, let's just cache all the users in the memory. Like, we get the beefiest box and like deploy it out there. But guess what? Like, you won't be able to even like fill that box by 50% because you already hit the packet flow limitations. No matter how much data you put, there's like the constant amount of megabytes you could read from that box out. So you have to stick with smaller boxes but bigger in number, which means you have noisy neighbors and all the awesome Amazon FX ready to like take you down. Once again, like, higher memory boxes doesn't work, so you have to shard early, shard very often, have replica caches, and that's the only way you can survive. And hard to get boot up failures. Like, this is one of the favorite things. Like, okay, we're gonna treat a traffic surge. Like, let's just boot up 10 more boxes, and we click the buttons, and it doesn't work. Because like, it's our Puppet, like, which is a totally different discussion. Like, it was not able to give, so first of all, the server came up, and the server was faulty for some undisclosed reasons, and we try to get up the boot up failures. So you get into Amazon AWS, click the right click, show me the system log, and you don't get the log. We don't know why. Sometimes it just happens. And there's like all sorts of kernel panic, and most importantly, this system log is a 4 kilobyte buffer, so if you are noisy on boot up, you don't get to see the awesome part, which is why your boot up is failing. So it's just a shot in the blind. Like, you don't know why your server comes up and dies all the time. So you're not able to auto-scale, and you're not able to handle the traffic which you should be handling. I could go on and on like this forever, but once again, like, we hit like, okay, a security group can only have 100 rules. You cannot have more. Firewall issues, new instances that come up, like, oh, I'm a memcache, I'm supposed to listen on 11 to 11 port, but yes, guess what? I'm not gonna respond on that port for the next 5 minutes because I'm new. I need to get my configuration from the Amazon master database or whatever. So new instances that come through auto-scaling need at least like 20 minutes or 15 minutes to warm up to even like be part of production. So we just like write sleep code and like, okay, sleep, can I reach it? No. Sleep, can I reach it? Yes. Okay, then push it to production. And this is something new, like Amazon S3 upload, like Jeremy hit, like recently. Whenever we back up the MySQL databases, like we create a huge star, like a couple of terabyte, and upload it to S3. And when you do this is like single-threaded, like we upload all the terabyte in like 3-4 hours. So we had a start like where we could actually like split this big file into small chunks and upload it to S3. And Amazon S3 has a beautiful multi-part MIME type where you could upload. But guess what? Like, how do you like actually make sure every chunk is in S3 safely? You cannot really when you do the multi-chunk, you basically lost the ETAG capability. You cannot do an MD5 checksum. So once again, like, oh, the optimization we wrote doesn't really make sense. But luckily, like Amazon found a way. like they have some internal APIs where you could like munge all these chunks and form one big file, and they'll give you the MD5, and you could check like, okay, the file is safe and it's uploaded successfully. So once again, like when you write some file to S3, you can't read it back. It says like, I don't have this file. We don't know why. Once again, the beautiful Amazon effect, like they gave an API where we can hit after every write, which will make that object persist and is available for every read later on. And when you're moving data between regions, it's really painful. TCP doesn't really like work here, so we were investing in protocols like Tsunami on top of UDP. And the last but not least, everything is ephemeral. No node is here to stay forever. Anything can disappear anytime. And that's where I wanted to like stop this list. And Puppet versus AMI, like we early on did not invest in Puppet, so in configuration management, so we slowly started using Puppet, which has been providing configurations. But once again, Puppet has not been fast enough to give this configuration to 50 new app servers, which should be in the fleet by now because there was a huge traffic spike. And that was another failure, so we started leveraging on AMIs. We bake AMIs every day, so we wrote a tool called AMI Factory by one of our ops guys, which entirely powers our new servers, bringing new servers into the fleet and all. And just Puppet just gives like, these are the list of files you should be having, but everything else comes from AMI. So once again, we're good. Couple of tips, like whenever you think you are on M1 XLR, you don't know what is the CPU underlying. Some boxes are just bad because they're old, and you don't know what kind of processors they have. So some people like run some bootstrap scripts and like to determine, is this EPS volume good? Is this server good? Should we keep it or kill it? So we don't do much of it, but we bring it into the fleet, monitor it for 5 minutes. Sometimes we just kill it because it's bad. EBS is convenient for root, like, but we do not rely on that. Like, we still use AMIs, and only the new autoscale instances use EBS because it's faster to get servers into the fleet. Regions may not be completely isolated. You guys should go and read the PagerDuty's awesome postmortem where they thought they were multi-region, but both the regions were connected to the same peering network, and when the network was down, like, both their regions were down. So regardless what they thought they were highly available, they were not really. So always keep, don't rely on AWS services too much. Like, we know how to run Memcache. You don't need to really like use Elasticache or something because it's nothing but Memcache on Amazon servers. So I highly recommend like do the homework yourself and just use the bare minimum, which is what AWS gives you anyway. So keep the data center move as part of your architecture. VPC is awesome. Get in early. Just don't be like us. We are too late, so it's not easy to move now, but there's an effort going on. Last but not least, I want to wrap up this talk as AWS is just raw power. They give you these awesome virtualized machines, but apart from that, they don't give you anything else. You have to write all the tools, like backing up, like building up AMIs, like all this stuff is all your work. You got to build this for yourself and scale this thing up. So that's where I want to. And moving forward, like we want to make pinning experience better uptime, lower latencies. Like this has been our goal for like a lot of quarters, and like it's been an ongoing effort, and it's going. And we're carefully evaluating like a data center move, but who knows, like could be on AWS for a while, or we might move, but still a decision we are yet to make. Continually collaborate, build bigger, faster products, 140 pin employees and beyond, and we are very excited for 5.6. The global transaction IDs is what we are super excited about. And with that, I want to wrap up the talk. Thank you.
Hi, my question is on, you touched upon DR. Can you tell a little bit what you did for disaster recovery?
We instrumented some stuff. Maybe, do you want to take that? Like, actually, like it's your domain.
Can you please speak in the mic? Yeah.
So in general, the disaster recovery has to come down to each individual type of thing that you're planning for, persistent stores and stateless stores and vice versa, with the recovery point objective and recovery time objective to get back up as quickly as possible. So it's a little too broad, to explain the whole thing, but taking individual things and make sure that we can actually automate our way to recovering things from, infrastructure as code and some data to get the time up. And coming back to Yash's saying is that we have to do this anyways for automation. Like if we can't promote a slave to a master quickly and then get new machines back up to revalidate that chain very quickly, we have to do that work anyway. Just trying to figure out how to do it at scale to suffer an AZ outage or a region outage or vice versa.
I love your Badgers jacket, but can you introduce yourself? What's your name and what do you do at Pinterest?
Oh, so I'm Jeremy Carroll, little footnote in the lower right-hand corner. So I work on site reliability at Pinterest.
Thank you.
Thanks.
Hi there. So I wanted to ask, what did you feel was the real tipping point for you to decide to obviously switch away from AWS? I guess that's what you were sort of saying at the end of the talk.
AWS to data center.
Yeah.
That thing has always been on the table. Earlier when we were when SSDs were not available and we were crazily splitting shards, we spoke with a lot of other folks like Facebook and others, and everybody's we're on SSDs, so we're fine. You had to worry. We were oh, okay, sounds like SSD is the secret sauce we want. We did a little evaluation, should we just move our data stores and can we have some special network pipe between AWS and this? And then anyway, they just gave us SSDs and we were happy. And once again, we have that on the table, but it's not we are constantly working, we're gonna do this at 2015 or something, but it's just on the table forever. Every once in a while, we just should we just move to data center and fix network forever? But who knows, but it's not we're gonna do this, but it's on the table and we're carefully evaluating every quarter.
Hi, I'm Pierpaolo. I'm with Dropbox, and I'm one of those that deal with this part of the system, so I feel you a lot. I feel everybody in the audience that deal with this. One thing that tickled my attention was the packet rate. I'm familiar with most of the other stuff, probably pretty much all of it, but that one specific. Can you elaborate a little bit about that?
There are some cache pools which required very high read throughput compared to write throughput. So there are maybe 2 cache pools at Pinterest where we try to cache everything because we can't take a database hit. So we gave a beefier box. But guess what? Nothing got better because the packets per limit is 50,000 something. We clearly see the ganglia graph. It's just constant, and we're not able to fill the cache enough. So we were oh, this ton of memory, and what exactly is happening here is we just hit this in a virtualized environment like AWS. There's a constant throughput that you can extract from these machines, and the first limit is you will hit the packets per second limitation before you hit the other things. So we just always have an eye on this. How is this pool performing? Has the features changed? And once we hit it, we know our lessons. Oh, guess what? We can't go beyond and cache it, so we have to go with more smaller instances, which means deal with more failures on the domain.
I'm just curious about that. I'll have to talk to you offline. But so you're saying that you're trying to do 50,000 or more network packets per second out of a beefy box, and you're running into a plateau in terms of performance?
Yes.
Okay, I've seen that twice before in different applications, and in both cases it turned out to be the same problem. So I'm curious to find out a little bit more about that. The other thing I was interested in, with your SSD usage, are you using the cheapest possible SSDs and you doing multiple copies, or do you tend to go the other route, which is to have more reliable SSDs?
So we use high 4XL machines, which is this, not the smallest SSD if I'm not wrong, but it has 2 1 terabyte SSD drives and 60 gigs of RAM. So I don't know which instance. There are 2 SSDs. I don't know the other one because we never used it. There's 240 gigs of RAM or something, so we don't need that.
Yeah, but do you tend to worry about the reliability of the SSDs and just go with the cheap ones and then just make sure you have lots of copies of the data, or do you try to not go that route?
I'm not sure what do you mean by cheap SSDs. They're like, so basically the pricing is almost the same for the bigger SSD and the smaller SSD. We tend to use the smaller SSD because it's working fine for us, and we were able to consolidate like 4:1, and we have fewer MySQL instances now.
Yeah, okay. I'm just working on a project where the guy doing the storage side of it is looking at ultra cheap, unreliable SSDs for very massive data store, but they're just going to make sure that they have like N copies of the stuff, as opposed to having something that's considered to be an enterprise-worthy, more expensive, reliable SSD, and not have like 4 or 5 copies of the data.
We have 2 copies, but I'm happy to talk to you offline.
Okay.
That's the time we have for questions. Let's thank the speaker again.